Let's use what we know about Kirchhoff's current law, Kirchhoff's voltage law, and Ohm's law to solve this problem. The circuit in this problem utilizes multimeters to tell us information about the current that passes through different components and the voltage drop across a specific component. The first thing I would do when solving this problem is identify the given information and put it on the circuit. That will help me see what exactly is happening with the different parts and the known information. I know that the current I1 is 0.325 amps. I also know I2 is 0.925 amps. I3 is 0.415 amps. And the voltage drop across that R3 resistor, as determined by the multimeter, is 1.3 volts. I also know the value of R1 is 10 ohms. Now that I have the known information labeled on my diagram, I can start dissecting the circuit diagram to understand how the resistors are connected in series and parallel. The first thing that I notice are these 4 voltage sources. At first that might seem a little intimidating, but this is as if you just have 4 AA batteries connected in series, one right after the other. When you have them in series like this, you can just add those together. 4 AA batteries, each 1.5 volts together would be 6 volts. So I can erase the 4 sources and write them instead as one voltage source of 6 volts. Writing it as one voltage source helps to clean up the circuit. It makes it easier for me to see the connection of the resistors within the circuit. The next thing I would do is identify the nodes. Identifying the nodes will help you understand what's in series and what's in parallel. In order to identify the node, you'll highlight the connected space within the circuit without crossing any circuit components. With the first node starting at the power source, we'll label the first node 1. Then we'll continue and identify node 2. Notice when I identified node 2, I did not include the multimeter. The multimeter is measuring voltage and therefore is just simply across components. It's not part of the circuit. When we're measuring current, it's part of the circuit. So the multimeters that are measuring current will be part of our node. As shown in this next node that we're identifying, notice how the multimeter for current is part of the circuit and therefore I have to include it as part of my node. It's not a circuit component. It's like it's just a connective material and just measuring what the value is of current at that point. Same thing with the multimeter measuring I3 and the multimeter measuring I2. That will be node 4. Now that I have my nodes identified, I can better see where current is going to split on multiple paths from node to node. The next thing I would do in order to solve this problem is I would redraw the circuit. The way it's drawn right now is a little complicated and it's difficult to look at with all the multimeters. So I would start by redrawing the circuit with the voltage source of 6 volts. Then I would move to the first node. When I redraw circuits, I like to draw them in this way. This is just my own technique. I label the node, and then I look on my circuit that I'm redrawing to see if there's multiple paths and how current will behave at that node to get to another node. Knowing that I'm going from node 1 to node 3, I can see that there's 2 paths. I can go from node 1 to node 3 by crossing R1, and when I see that, and I can go from node 1 to node 3 by crossing R2, taking a pit stop at node 2, jumping over R3, and reaching node 3. When I identify that there's 2 paths, I'll draw that in my redrawn version of the circuit, and then I'll address each path individually. The first path goes across R1, and we know that that is 10 ohms, and then reaches node 3. The second path goes through R2, takes a pit stop at node 2, then goes through R3, and connects to node 3. From node 3, I can see that there are 2 paths to get from node 3 to node 4. So on my redrawn circuit, I will label 2 paths, and then I will address each path individually. The first path goes across R4 and then reaches node 4, and then the second path goes across R5 and then reaches node 4. Node 4 then connects to the ground of my voltage source, and I have completely redrawn my circuit. Next, I need to make sure I identify the known information that I had on my initial circuit on my newly drawn circuit. I know that the current that passes through I1 is 0.325 amps. That's the current after it passes through R1. So I can draw that current here and label it as 0.325 amps. Then I know that the voltage drop across R3 is equal to 1.3 volts. Current I3, which is the current that passes through R5, 0.415 amps. So I can label that current I3. And then finally, the other known information is after the current that passes through R4 and R5 comes back together, the current is measured as I2 to be 0.925 amps. That's the current that goes towards ground. Now that I have all my known information labeled on my newly drawn circuit diagram, I can more easily solve for what the problem is asking, the value of R2. So when you're solving this, it might seem a little overwhelming to find the value of R2. You need to take a step back and think, what do I know and what can I use in order to find that information? The most information that I know is about R1. That's the only resistor that I have a value for. I also have the current that passes through it. It is in parallel with the R2 and R3 resistors, and R2 is the resistor of interest that I'm trying to find the value for. Looking at the current that passes through R1, I believe that I can find the current that passes through R2 and R3. Knowing that the value of R1 is 10 ohms and the current that passes through R1 is 0.325 amps, I can find the voltage drop across R1. Once I find the voltage drop across R1, I can use that information to find out more about the components that are in parallel to R1. I might also be able to use the current to find more information about that part of the circuit as well. First, let's find the voltage drop across R1. If we're finding the voltage drop across R1, it's going to be the current related to R1 times the resistance value of R1. The current through R1 is 0.325 amps. The resistance value is 10 ohms. When you multiply that out, you get 3.25 volts. If we have the voltage drop across R1, we can know the voltage drop across R2 and R3. Because R1 is in parallel with R2 and R3, the voltage drop has to be the same. Imagine if you were a multimeter and you were measuring voltage here. That's the same as measuring voltage here or measuring voltage here. You're going to get the same value because those are connected at the node, and since they're in parallel and according to Kirchhoff's voltage law, we know that the voltage drop across one component in parallel with the other component has to be the same. So knowing that the voltage drop across R1 is 10 ohms, I know that the voltage drop across R2 and R3 together is the same value of 3.25 volts. Now that we know the total voltage drop across this section, the R2 and R3, I can find the voltage drop across R2. If the total voltage drop across this section is 3.25 and the individual voltage drop across R3 is 1.3, then I can say the change in voltage across R2, the voltage drop across R2 is equal to the total voltage across that section minus the voltage drop across R3. So I can say that's equal to 3.25 volts minus 1.3 volts, which is equal to 1.95 volts. So I'm trying to find the value of R2. In order to find the value of R2, I need to also know the current that passes through R2. Now, do you see how we can find the current that passes through R2? I know that the current that goes towards ground is 0.925 amps. If that's the current that goes towards ground, that's also the current that leaves the power source because that's the total current in the circuit. So the current that leaves the power source is 0.925 amps. And if 0.925 amps is what enters node 1, I know what's exiting node 1 is 0.325 amps, and whatever the value of current is that passes through the R2 and R3 resistors. According to Kirchhoff's current law, that value of current that goes through the R2 and R3 resistors has to be 0.925, the current entering the node, minus the current exiting the node, 0.325 amps. Because of KCL, we can say I is equal to 0.925 amps minus 0.325 amps. That current that passes through R2 and R3 is 0.6 amps. Now, if we know the value of voltage drop across R2 and we know the current that passes through it, we can find the value of R by applying Ohm's law. Ohm's law states the change in voltage across R2 is equal to the current that goes through R2 times the value of R2. We know the change in voltage is 1.95 volts. We know the current is 0.6 amps, and we're trying to find the value of R2. R2 can then be calculated to be 3.25 ohms, which is answer C in the answer choice bank. Notice when solving this problem, we were able to peel back the layers and use only this top portion. We never needed to use the information in this bottom portion. Now, there are other routes that you could have taken to solve this problem, and so I encourage you to experiment and find different pieces of information and see what you can learn about the problem.